You're listening to a new episode of The Brave Technologist, and this one features Jack Pertschuk, who is a principal engineer at Pinecone, the market leader in vector databases. As the company's founding engineer and lead for algorithms applied research and platform, Jack is responsible for roadmap and execution across research and engineering for search index efficiency and accuracy. Prior to Pinecone, Jack was founder of SidekickQA and creator of the NBoost open source neural ranking engine. He is an active member of the Rust and Information Retrieval research communities and is passionate about solving problems at the intersection of ML and systems. In this episode, we discuss the power of vector-based databases, difficulties in promoting a solution when the problem isn't widely understood, why he's going all in on hybrid retrieval and search, along with advice for teams adopting vector search for the first time. And now for this week's episode of The Brave Technologist. Jack, welcome to The Brave Technologist. How are you doing today?
Doing excellent. Thanks for having me, Luke.
Just to kind of set the table a little bit, I know you're one of Pinecone's founding engineers. Can you help our audience understand a little bit, what does Pinecone do and what kind of area are you guys focused on?
Yeah, for sure. So Pinecone set about making the sort of cutting edge neural search and database technology for building ML powered and AI powered recommender systems, search systems. Think about, powering like a Facebook news feed or showing you similar related items when you check out in your Amazon cart, right? The underlying technology to do this at large scale was previously only accessible to large tech companies. And when we founded Pinecone in 2019, we wanted to basically democratize it and allow anyone to easily build systems based on this fundamental underlying KNN or vector search, vector database functionality.
Cool. What kind of first drew you into this work at the intersection of ML and these systems?
So I actually got into entrepreneurship in undergrad. My senior year at Cornell, there was a really strong entrepreneurship community, and I started competing in all these contests with some of my friends, and we started winning. And we just were building. I mean, we did pitch competitions. So really, it's a lot more about having an idea for a company and being able to sell it compared to actually building it. But this was enough to sort of whet my appetite for, what might be possible with ML technology, database technology. We got into the pharmaceutical space. We started building tools for searching and indexing data in pharma M&A. So, there's tons and tons of clinical trial data, massive volume that, legal assistants and due diligence people spend hours and hours and hours sorting through. And so we built an ML-based platform for analyzing and searching that data. And as part of that effort, I, came into contact with this neural search AI technology and deployed it for the first time. But it was really hard. What existed was some open source libraries like Face, HNSW, a few things you may have heard of. But to deploy them, me and my buddies hacking away in his mom's basement actually just spent hours and hours spinning up infrastructure. You hit a lot of out of memory for the systems people because these are very memory intensive algorithms. And it was just a huge pain. You needed to be almost an expert in vector search to build an application based on this. And so then when I came into touch with the Pinecone founders shortly after my graduation, I understood the mission and I understood the value of what they were trying to build.
Awesome. So, I mean, it sounds like really a total startup, right, mindset of okay, kind of getting the pitch part down, but also a really interesting mix from what I'm hearing. And this is I can kind of relate to working on the production side where you're hitting these software or hardware limits too. You kind of got to get a balance of your hardware chops along with what you're trying to do with the software. What was one of the biggest early challenge that you guys had when you were starting Pinecone?
Yeah, I mean, the biggest challenge was just no one knew about this technology outside of, a very insular sort of data science, ML, big tech community, right? It's sort of it's easy to explain, right? You just want to find similar content in high dimensional space. But for folks without a math background, I think understanding the value of it and why you need a database for this and the sort of applications you can build with it is difficult. And it requires a lot of actual knowledge. You have to train an embedding model to produce these high dimensional representations. And then you have to index them. And then you have to build an application on top of that for end users that actually adds value, right? Like a search application or a recommender or some sort of end user product. And so having all of these pieces together, there were only a few companies that really did this and pieced it all together. You think, Etsy, I think had a big team, Pinterest, these companies where their core value is really about the search and the recommender understood this technology, but other folks just didn't have the background and context to think about what sort of systems they could build with a vector database. And so, we struggled to sort of communicate that to customers, educate people. And that was a big part of our success as sort of the thought leader in vector databases. Even just the word vector database, the term, it took us so long, so many iterations. We called it neural search at first. And then we thought, oh, hey, it's really more like a database. But then we started calling it a vector database and people were confused because they thought it was vectorized instructions, which is a different thing. Right? Another systems concept. It's, vector is a very overloaded term. We tried calling it an embedding database. We just had all of this sort of like A/B testing around, how do we even talk about this thing? But once we landed on vector database and people started, using ChatGPT, understanding what AI was and what the value of it was, everything clicked. And we educated people about how they can use vector databases to build, a wide variety of AI-powered applications.
I'd imagine too, you said you guys started up in 2019? That feels in this space ages ago, right? And like even within the past, think about the past year, right? This is the first time in a decade that Google query volume is actually going down. I would imagine that AI is actually kind of making a dent into how people are searching for things, right? I would imagine that communicating that it's an ongoing thing, right? Like how do you communicate the value, but also how is the product market fit changing, right? And because the behaviors are actually starting to change. How much are you guys thinking about that, and how much is that impacting what you guys are doing?
Well, I think there's a lot of discussion about, RAG, retrieval augmented generation. This is a concept that was really buzzy a year or two ago. And essentially, models had much more limited context windows where you could only put 1 or 2 PDF documents probably in the context of the model at that time. And so you needed to do an initial search or retrieval stage to actually find the most relevant content to help augment your query or your GPT session, right? And so, model context windows expanded quite a lot in the last year, million token context windows. And so folks are increasingly relying a bit more on just putting everything in the model context, but it's actually not a good approach, right? We've shown in the research that we've done, the research that other folks have done, that it's still much more effective to find just the relevant content, give that to the model. It's also, of course, way cheaper. You're not paying for all these tokens and just like stuffing them into the model. And so there's a lot of nuance here where these things kind of go, it's just like a pendulum swings back and forth. Everyone's like, oh, you need a whole retrieval stack. Oh, just put everything in the model context window. Really, the truth can often be somewhere in between. But in general, we still view, and I think most, serious people in the space still view retrieval as a critical part of the modern AI stack. And folks are using more agentic retrieval methods as well in certain circumstances where you go, maybe grep for like a specific pattern in your data set, and then you give it to the model, you didn't find what you want, you go back, grep for something else, so on. And there's popular AI tools that use this pattern. But in general, it's much slower. And, for different applications, a hybrid of both these approaches can be effective. And that's one of the research areas we're focusing on here at Pinecone. And we have some upcoming products that are going to address this hybrid retrieval scenario where you have both a vector database and you have something more agentic running to actually iteratively look for the content that you want to find. And then, if you don't find it, go back and sort of look again.
So continuously, like taking small little passes at it, right? Like until and refining on that and kind of getting it versus like eating the whole watermelon in one bite or whatever, which is what it felt like. I feel like it's got to be an interesting part of this too, where you see these companies with their products and they come out and everybody kind of picks these arbitrary cost price points for this stuff. And then all of a sudden you start seeing all these like $200 a month, $300 a month, right? Like where you're like, these costs it seems like a hard thing to kind of like predict what the cost of these things would be and how fast the hardware would, iteratively improve, right? And become more efficient and cheaper and all of that stuff. How much on the behavior side are you all seeing things change with use, or are you seeing it at all? Is it much more like just communicating with developers right now, or are you guys seeing like actual changes in behavior from users with this stuff?
I think end users at the end, like ultimately just want something to work.
Right.
They ask a question, they ask for, they're like, okay, modify my backend to fix this API authentication issue, right? And so a developer, they don't care how you're doing the search, whether it's a vector database or whatever. They just want, to get the relevant content, the documentation for the API backend, the files that handle authentication, send that to the LLM. run the agentic process, edit the files, find the bugs, fix the bugs, so on and so forth, right? So for the end user, in an ideal world, they don't have to think about retrieval at all, right? The vector database is almost invisible. It's just something that magically gets the context that is needed. And we talk, this term context engineering is getting a little bit more popular, right?
Yeah,
And
you're
this
hearing
is something.
context everywhere. It's like the new
Yeah,
buzzword,
yeah.
right?
Context is king, right? Context is
Yeah.
king. And I think application developers are increasingly realizing that having the right context is the key to having a good AI user experience with accurate and grounded answers.
And so you kind of touched on it a little bit, like hybrid search, right? And then this cascading retrieval. Can we walk through the audience through this, just a flow for this so they can kind of understand it? Because I feel like it's something that's pretty important for people to understand more. And I feel like I'm feeling it when I use things more, right? But I wonder if you might give it a little bit of a breakout of what that means.
Yeah, so a hybrid and a cascading retrieval are sort of different approaches for combining multiple search methods to a merged result set that contains all possible information that you might need for a given, question or interaction with an LLM, right? And so what that means is that the semantic meaning and representation of text or a PDF or an image or a document is very well captured by the dense embedding, right? We talk about vector embeddings, right? The LLMs, they're essentially latent representations from the inside layer of the model, right? And so you can think of it as like a snapshot of the model's brain. And so what you do is you just sort of like take these snapshots and you put them in Pinecone or vector database, and then you search through them, right? And these snapshots of the model's brain represent what actually is going on in that piece of content, right? If it's a PDF, an image, or whatever. And so this is a very powerful way to find everything that is conceptually similar to a given, piece of text or a query. So this is the dense retrieval component of cascading retrieval. And this is what you primarily use a vector database for. But sometimes these searches can miss specific context, right? So let's say you have like a name of a function or a file that the model has never seen before, right? It won't necessarily map cleanly onto a specific, area of the brain. The model doesn't actually know how to perceive or understand this because it's something private, specific to your workspace, specific to your problem. And so it can be helpful to also do an exact text search, like a full text matching in a traditional style with that, file name or this thing, right? So this is called like a sparse retrieval or a full text retrieval and a lexical search. And so what you do for a hybrid retrieval or cascading, the reason we call it cascading is at the first level, you do the dense, like I was talking about with the latent representations. And then you also do a sparse retrieval that's a full text or exact matching. And then if something was missed in the dense retrieval or the sparse retrieval, it's fine. At the end of the day, you merge them, right? You cascade them up into a second layer pipeline. You merge results, you run through a model again. The model tells you, okay, I need this result from this result set is interesting. This result from the sparse result set is interesting. And actually that way you don't miss anything. You're maximizing recall is what we call it in the first stage, which means you want to you're casting a wide net. You want to get everything that could possibly be interesting. And then in the second stage of cascading retrieval, you maximize for precision. Precision means then you go through and you drop the results that are not interesting, right? But it's easier to do that because now you've filtered the whole data set, might be millions, hundreds of millions, billions if it's web scale, right? And you filter that down to a smaller candidate set, and then you can maximize for precision, just weed out everything that's not actually relevant. And then you have a final result set where you're guaranteed that you didn't miss anything, but also you don't have anything in there that's not relevant. You give that to the model. It minimizes the amount of tokens you have to put in and maximizes the speed. And you're guaranteed that is the most relevant content for the model to answer the given query.
It's fantastic. And it all just happens like super fast. And the end user doesn't even realize it. It's so crazy. Like it's so powerful. I'd love to touch on something a little bit too, because I don't have the opportunity to talk to folks like yourself in this detail too often. You mentioned there's something the model hasn't seen before, right?
Yeah.
What's the rate in which the new things are adapted and kind of like incorporated into the model's knowledge, right? So like, let's say that I'm giving the model something it hasn't seen before. Is it learning from that one instance, or is there a certain amount of similar things that have to happen before it learns something new? I think folks might just be kind of curious a little bit how that works.
Yeah, so that's a great question. I mean, actually, I think at this point, my understanding based on what most of the big labs do is actually it's a much more offline static process. So you have especially for pre-training, right? you have a pre-training run that probably, it might take a month to actually run the full pre-training on, and these are usually, multi-petabyte, many petabyte data sets that are being run through the pre-training phase. And so the model's knowledge actually just captures a moment of time that is usually like months prior. So GPT-5, for example, I don't know, I'm not even sure when that pre-training happened, and I'm sure that they incrementally update the pre-training a bit, but the snapshots that are running in production today for GPT-5 and stuff, I would be shocked if they're they have any sort of innate knowledge that's more than a month old, like the actual model weights. And now folks are augmenting those models, and I don't know the exact details of that, but this is actually where RAG comes into play a lot, right? Where, okay, the model has basically all the knowledge that was available to it a month ago when we did the pre-training run, right? And when the model waits, and it's sort of like, it's snapshotted there. But then you can obviously, apply some extra information and search to the interaction. So when you go ask GPT-5 about what happened today, or like so on and so forth, it has tools that it has access to that allow it to access the information that's more recent, right? And this is, again, with retrieval, search, RAG, where the point of it is, you don't always want to have to update the model weights because it's expensive and it's hard.
Right.
So rather than trying to cram all the knowledge, getting the model to try to memorize tons and tons of specific details and information, you actually just want the model to be very good at reasoning and it have some world knowledge, like some innate basic knowledge about everything. And then you want to augment the interaction and give the model all the extra knowledge it needs at query time, inference time, so that it can answer, the question and add the extra context. And that's sort of the point of RAG.
It's awesome. I mean, like, you totally see it too as people using this stuff. They used to timestamp this stuff and say, like, look, I'm only this relevant, right? Like, and then nobody wants to see that, especially I feel like a lot of this kind of correlates with just people using these prompts more for, everyday search. But I'm kind of curious too, there's a lot of concerns from like content creators, publishers and stuff around this. Do you see tooling and databases like what you all are doing being integrated more by publishers and content creators to get more functionality and utility to what they're doing, or is it kind of a separate bucket for you guys?
So yeah, I mean, we don't directly provide public search APIs or anything that would cover that sort of proprietary IP and content, and we're not collecting data and training models on it. So we haven't directly dealt with any of those issues. I know there's been a few lawsuits and a lot of talk about it. I think that in general, we're going to have to answer a lot of questions about who owns, who owns intellectual property in the AI era, because it's frankly just like, it's too hard to attribute and know where everything came from, because it's, at the end of the day, it's math, right? It's like big matrices, and, there's a lot of work around mechanistic interpretability that folks are doing to sort of understand what are these models thinking? How do they work? It answered in this way. This content came out. Where did it come from? Why did it come out? How do I like surgically edit that out? Right. And I know there's a lot of research around that, but yeah, in terms of retrieval, it's a bit of a different problem space.
Yeah, no worries. I was just always kind of curious. And we touched on this too a little bit, like all these retrieval process is all happening and there's like a lot of reasoning involved, right? It obviously feels like this stuff is getting better and better, more and more accurate, right? How do you guys measure when something's good enough? I mean, I'm sure there's many ways to measure when something's good enough, but like, for the layperson, right? Or somebody that's using this, how do you explain that to them?
That's a great question. I mean, in some senses, that is the most important thing for building ML and AI systems, right? Evaluation. And we have a bunch of rigorous internal tooling for evaluation, and we've flirted a bit with, productizing it and launching it. And I think that we've worked with some customers one-off to sort of help them, evaluate their retrieval system. We have scientists that will embed with customers and help them understand if the search system isn't returning the results that they want, then why. Knowing when it's good enough, I think most folks have an external business KPI that they're looking at, right? So if you're building a search system, you're looking at click-through rate. Are people finding the content that they actually want? If you're building a recommender system, like, are you converting people to adding stuff to their cart, right? Are people buying more? If you're building a social media platform, it's engagement, right? Like, are people staying? They're clicking, they're watching the videos, right? So there's not one size fits all sort of evaluation for a vector database like retrieval application. In terms of LLMs, and this is where I think folks, there is kind of either it gets the answer right or it doesn't, right? There's a
Right.
clear way to evaluate it, right? And so we have data sets that are synthetically generated for, specific applications like finance, right? And there's, data sets out there like Finance Bench is one, and a few other that are, human curated, where you have a set of questions, you have a set of documents, and then you have a rubric, essentially, right?
Hmm.
And this is one of the things that a lot of folks in AI are investing in heavily right now. Mercor, right, is very, they just passed, I think, 500 million in revenue or something crazy, just based on building these data sets, hiring people hourly to grade, design rubrics, generate data to evaluate LLMs, right?
Hmm.
And so once you have that data, you kind of look at two things, right? If an LLM got the answer to a question wrong, did it not have the relevant context, right? And again, this comes back to
Hmm.
sort of context engineering, where if it didn't have the relevant context, then you have a problem in your retrieval stack. That means maybe you need an approach like hybrid retrieval. You're missing results, so you need to add lexical search, or your dense model is not performing like it should. And so then you go in and there's common metrics. And information retrieval is the field of research. You look at MRR, like median reciprocal rank, is a way of measuring essentially like how far up in your search results is the correct, most relevant one, right? And these sort of metrics people look at, and you might say, oh, your MRR is really low, or your recall is really low. You're missing this document, and that's why the LLM got it wrong. And that's one of the reasons people choose Pinecone, because we also optimize for recall within this approximate nearest neighbor space. When you're searching the dense embeddings, it's too expensive to do a full scan of your data set, right? At
Hmm.
runtime, it's going to take a really long time. So we build indexes to optimize that, but those indexes are approximate. So they're approximate nearest neighbors. It means, you might miss maybe 5% or less of results, but oftentimes those 5% are not even going to be necessarily the ones that are the top. And so what we optimize for in building Pinecone in these algorithms is, okay, are you getting close to 100% of the context results that you need to give the LLM to answer the question properly, right? And then if the LLM has all the context, your retrieval stack is actually performing as expected. The metrics, the MRR, the recall, you're not missing any documents in your search. You're giving the LLM what it needs, but it's still answering it wrong. Okay, then it's a reasoning problem, right? Then it's an
Hmm.
LLM problem where, you need to do more RL on the model or train it, fine tune it in some way to improve the accuracy.
It's wild, man. It's almost like you're kind of putting like mini SERPs and everything, where it's just like, because I'm thinking about it as you're talking, I'm kind of thinking about how summarizations have evolved too, to where initially it's just kind of breaking down a few bullets of something to now you're seeing these richer and richer data and text
Right.
and images and all this stuff kind of coming together. And at the same time, you've got agenic, which is like a buzzword in itself, right? Where it's like it could mean so many different things to different people
Right.
in different businesses, right? Where it's like, gosh, if you're measuring off of click-through rates or something, well, what happens if a genic product, insertion or something just makes it irrelevant to even need to advertise the thing anymore, right? It's just so wild,
Yeah.
like how wild west the space is kind of right now, but also just like how robust what you all are doing it is actually is, and how it just feels like natural to the end user. Or even if it misses, I can just follow up with a quick, no, let me steer you this way a little bit, and then get that follow up. It's really interesting. What innovations that are happening in vector search today that are most interesting from your point of view?
I think hybrid retrieval is probably the area where, the most gains are being made, because a lot of folks originally built sort of dense retrieval applications, and they realized that it wasn't exactly returning all the results that were needed. Like I, mentioned before, you're sort of missing out on those benefits of cascading or hybrid retrieval. And so, actually building hybrid indexes with full sparse component and a full dense component and merging those results in an optimal way in sort of instant latency is actually hard. That's like a really non-trivial problem, because you don't know necessarily, how many dense results, how many sparse results. These are sort of like two different indexes. You retrieve them, and then, merging, there's a lot of different algorithms for that. And so, one area I would like, there's been a little bit of research in this, and this is an area I'd like to invest in more, is training a model for hybrid retrieval in and of itself, right? So right now you have models for sparse, or you can use like TF-IDF, BM25, like traditional full text matching, and you have models for dense, right? And there's sort of approaches like Splade, which produces like word piece tokenized sparse embeddings, which are kind of it's somewhere in between, essentially, like sparse and dense. And these models have been shown to be really effective, and they do sort of document expansion and summarization as part of the indexing process, query expansion as well. These are techniques that are being researched and are very promising. So I think being able to train one model that produces both a sparse and dense embedding is something that folks haven't really been doing in production yet. And I think that would be really powerful, because then you sort of automatically get like a proper merging of these results. You get the best of both worlds, and you don't have to kind of, right now, if you're doing hybrid, you have to like tweak some parameters, right? And sort of like use a heuristic or guess. You're like, oh, I'm going to give like 0.2 weight to my dense and 0.7 to the sparse, or something like this, right? And we see folks, as we call it alpha, right? This like blend parameter. And so, if you could train a model that actually just had that alpha baked in and optimized for, and like learned that sort of way to blend the sparse and dense results in hybrid retrieval, that would be a really powerful step forward. So, I hope to see some folks publish on that soon.
No, it's awesome. No, super interesting. And also kind of given your background too, like this kind of coming from startup and also from the engineering side, is there any advice that you give teams that are adopting vector search for the first time? Maybe they specialized in something else initially and they're having, because this is something where, like, I don't know, I've been in startup too, like you've been dealing with this stuff for a long time. Like you rarely see something new that has this kind of C-level Fortune 1000 mandate to integrate something where, like, and also having this be so powerful. And like, I don't know, are there any pointers that you give folks that might be considering adopting this for the first time?
Yeah, I mean, I think if you don't adopt it, you're competitive as well, right?
Good point.
so it's kind of do or die, right? We've seen a lot of companies get really meaningful bumps in revenue from going full hog into AI. I think Databricks just had like a banner year. There's clearly ROI as like a digital native SaaS or database or any company that has a product that could benefit from AI. You are going to get ROI if you deploy it proper, right? Like we've seen that. And it doesn't mean it's easy, right? It doesn't mean it's easy at all. It doesn't mean it's intuitive. Evals are key, right? Come up with the metric that you want to optimize for. What is the problem? And be realistic. AI is not a panacea, right? This is not a silver bullet. It's not going to cure your revenue problems forever like magic. You can't just wave a wand. And so you got to be realistic. But if you have metrics, specific metrics that you want to push, and a specific way to measure the impact, and a realistic assessment that the AI technology, the retrieval technology will push those metrics in a meaningful way, a hypothesis, and you can be very successful and you can add a lot of ROI compared to your competitors.
That's awesome. Is there anything we didn't cover that you want our audience to know about what you're doing or stuff in general?
We're only at the beginning. That's what I'll say. This is the tip of the iceberg. When we started Pinecone in 2019, it was really, really early. It was arguably too early, right? But you're too early until you're too late. And I think that's one word of wisdom I'll give to people. You might feel like the AI models aren't there yet. You might feel like, the way I was doing it before is fine, but the technology will only get better. If you just stick with your legacy methodologies, you're going to get left behind.
Great note to end on, man. Finally, where can people check out what you guys are doing at Pinecone, or if you're publishing stuff or are active on social, where can people find you?
Yeah, for sure. You can follow me at Jack Pertschuk on Twitter. First name JackPertschuk with an underscore in between. And, Pinecone is constantly putting out new blogs. We have a Discord community that's just launched. And so, join, come, hang out, ask us questions. We love to chat. And stay tuned because, as I said, it's just the beginning.
Awesome, Jack. Thank you so much for being so gracious with your time. I really enjoyed this conversation. I'd love to have you guys back on too, to kind of check back in on things as we move from the beginning to, down the road, right? But thanks. This has been like really awesome. Really appreciate you making the time to come on today.
Sweet. Likewise. Thanks, Luke.
All right, cool. Thanks.
Bye.
Thanks for listening to the Brave Technologist podcast. To never miss an episode, make sure you hit follow in your podcast app. If you haven't already made the switch to the Brave browser, you can download it for free today at brave.com and start using Brave Search, which enables you to search the web privately. Brave also shields you from the ads, trackers, and other creepy stuff following you across the web.